This is a quick video explaining the table I posted on Piazza. Someone asked me to clarify it. Um, I know it's ambiguous because like I named stuff differently and stuff like that. Anyways, so um, to start with, we basically have two classes. One base and the other one is the derived class. So if we look at Compiler Explorer, which is a website that just does compiles your C++ code, I want to see. I want to show that we have a base class and we have a derived class, right? Now, for both of them will have a function, but this function could have so many states. Which one of them, let's say, the function exists or does not exist. Also, does it have virtual or does not have virtual? I want to point out though that this virtual affects the relationship between base and derived, right? And in the derived class, if you have another virtual here, it will affect the relationship between derived and if there's another derived class here, right? So it does not relate to what's above it basically. So let's remove this. And this is reflected on the table by saying, hey, not applicable, right? So we go under derived class, the keyword virtual, and not applicable, not applicable, not applicable. I think, yeah, not applicable basically to the function in the derived class. Excuse me. So here we have B, basically create a base class or we create a derived class. For the base class here, we access the function directly, and here's the output of that, right? And here we cast the base class, we cast it to derived class, and this is what we get, right? For the derived class, once we try it as derived, like just use it directly, and this is the output variations that we get. And if we cast it to base class, this is what we get, right? Now, all these situations, why they're different, just because of these inputs are different. What I mean by these inputs means a derived class will have the function, and it is virtual, so that's true. However, the derived class also has the function, so it's true, right? And it's non-virtual, that's given. The second case, for example, if you have the function exists in the base class, it's also virtual. However, the function does not exist in the base class, in the derived class. What would that will print out? Well, it prints out one of these, depends what function we use here. So let's follow up. Let's follow the table and see how the code will look like. So what is the first case? We have a function exists. Well, the function exists here, right? The word virtual is true, so the function is virtual. And the derived class function exists as well. So the function here exists and doesn't matter if it's virtual or not. We said that because that affect any class that inherits from the derived class, not what it inherits from. Okay, so to run this, first let's just do, let's call the function of the base class. Basically, we create a base class, and we just call, we create a base class with B, we call it B, and then we just call the function bfunc and see what that prints. And as you can see, bfunc should print the function itself, right? The function that belongs to the base class, and that's here. Because here we did like B, we just made a brand B class. We can just make it a base class, whatever. But just to follow the table make it like B class, bfunc, just to shorten it. But this is what caused confusion, I guess, because here's like base, derived, but here's like shorter name. So that's part of the confusion. Okay. Now, let's see what other will bring. So I'm not going to go over why it does this, because this table should be just summarizing for you in case you get like, sort of like, if you get confused or something, kind of like in the exam, you just check this and you use it right away instead of like rethinking about like how it happens and all that, because it's kind of like you already establish the truth basically when you practice or while you're studying, or like when you understand the topic, and then in the exam you don't have time, you just execute, right? And now since we got an extra day, you get time to understand this. Okay. Excuse me. So exist. We said bfunc will print the bfunc as we expected. Now, if we downcast, and what I mean by downcast, it means we have base class and we try to use it as derived class. Because this have more information as derived class, you can't downcast this way, right? So it seems that this compiler that I'm using is new, because I remember it wasn't giving me an issue. It will be just undefined behavior before, but I think if you use pointers, yes, but if you use references, will not. So what I mean by this, if you let it compile, it tells you that hey, you can convert from base class to derived class requested, blah blah blah, right? I think one way some people used to get around this, we just they create it by new, right? So now this is like basically this is a neat feature. They could just toggle them here, so that's not nice. So and you try to cast this, like whether you do static cast or you can just do just C cast, which is this, right? By saying hey, this is derived and it's a pointer. So basically this is what cast it. However, I think this is undefined behavior. So you never want to go from base class to derived class if the original memory layout is a base class, right? So this is why it was like undefined because of type, or you can just change this to a compiler error, right? Because we made it work, but through pointers, not through reference. So I'm just gonna return it the way it was. Yes, okay. So that's an error, and this is the function access, right? After that, we do. Let's just go the function first. We create a class called derived, call it d, and then this we just call the function here, and the function returns the correct function call, prints the correct thing, which is the derived one. If you call it with a casted pointer, so basically here we have a derived class that we casted up as a base class. So basically we limit it to its parent functions, right? If you don't have this virtual, it will print based on the apparent, basically the apparent pointer. Sees the pointers like, hey, I'm actually using base, so I'm just gonna deal with this pointer as its base, and I'm gonna call it the base function, right? This is if you did not have this as a virtual, but if you have it as a virtual, it'll actually call the underlying data, so it will be depending on this type instead of this type. So this is what virtual do, but yeah, check the lecture videos about this topic if you need more details. So this is basically how you can go about reading the table. The other case, which is like, let's say the second case, which is okay, this is virtual exists, but this does not exist. So let's just comment it out. This is like command and / because I think they're using VS Code under the hood here, so it's kind of like all the shortcuts works. Okay, so the function does not exist because we commented out, and we have here virtual and we have func. So like when it prints all of them B, right? There's no C's at all because D's, because excuse me, because yes, no such function exists, right? To print this. So B, and you can see here B, and this is commented out. Third level, which is the function exists, but it's not virtual, and it also exists in the parent and the child class, or the derived class. So what does that mean? It's not virtual, so let's just comment this out in a hacky way. And then if you go here, you do this. Let's see what it prints. So B, which is what printed here, and then another B, which is what was printed here, and then another D. Okay, the last one, which is exists, not virtual in the base class, and then it actually does not exist in a derived class. So let's what else? Yes, non-virtual. Yes, it gives you all B's, right? As this class does not have it. So you get a B, B, B. This is how I checked if the table is correct. Now, if it does not exist, if it does not exist in the base class, then you don't need virtual because that function does not exist, right? So let's try, but let's go around this. I assume some of these will fail. Yes, they did, but also the function actually exists in the derived class. So let's see. Okay, so it seems that we get some compiler error, which is 1, 2, and 3. Well, we only got 2. Yes, because we comment this out, so we only get these 2. So just double check the last one. Yeah, see? Now let's remove this. You're probably gonna get all compiler errors here. So yeah, you can't even compile the last ones. It is, guys. This is actually I want to point out about like some good stuff about this website, which is I think the assembly viewer. This is I'm just running it, and I think they don't have R machines, so they run it on x60 64-bit machine, Intel or Linux, I don't know. But the good thing is that it doesn't matter because that's a C++ behavior, not a compiler behavior, I think. So so it doesn't matter what architecture you run in, you just get a different assembly code for it. So there's an assembly view here. Let me try to. I had it. Oh, I think I just have to reset the layout to. There you go. So this is a very beautiful. You can change even the language here. You can choose C. I might have some code here I don't want to show because it remembers the code that you write. But here, you see, you can change here. You just say, hey, ARM, and I think I have it as, I have it as favorite. So ARM GCC 12, and it just shows you, see, stack, you get everything you want here, right? It just shows you all your code. Let's say you just do whatever, like, and I equals 0. Hopefully it doesn't optimize it away. So if it was optimizing it away, and it shows you the line, what this line produces, right? Like whatever this is. A good thing is to compile with the flag O, which is for optimization. Oh, sorry. O for optimization, you do 0, like you don't need any optimization. Should this produce more output? Maybe, maybe not. Let's see. It's probably the same output for some reason. Anywho, this is what I have to say, what I have to share. Anything else? No, I don't think so. All right, guys. Good luck. Thank you.